So good evening everyone. This is the first lecture in the lecture series of particle physics, where we will be discussing about the basics and most important topics of particles that are really important to understand in order to go further in the direction of particle physics and high energy physics. If you want to pursue higher studies in this field, this is your particle physics. In this topic, we will be studying. In this class, we will be studying about different type of interactions um, in nature and particles. So there will be four types of interactions in nature. You know this one, and that is a strong nuclear force, then weak nuclear force, strong nuclear, weak nuclear, electromagnetic force, electromagnetic force, and your finally that is gravitational force, or gravitational interaction. Which is the strongest force in nature? That is strong nuclear force, or basically nuclear force. This is what gravitational force. All right. So these are the interactions in nature. Okay. And these forces have very different properties and manifestations. Okay. And each force is associated with something called a mediator. Okay. That's something called a mediator. Mediator means what? What does this mean? Suppose we have a source of electric charge, mediator. Suppose we have a source of electric charge Q, right? And we want to know what force a small test charge Q experiences in its vicinity. So in classical physics, the answer is well known. That is, we express the effect of capital Q, this one, on small q in terms of what? Something called an electric field E vector, alright? Something called electric field E vector. So that is what? We know what? F F1 Q is what? Q vector. Okay. So this is the electrostatic force you can see. Alright. So what we say is due to the this is the force due to the source charge capital Q. Alright. It is a vector, each component of which is a continuous function of R. So because we know that if Q is equal to what? Q Q by KQ by R square R cube. Alright. Um, okay. Of course, the electric field itself is not directly observable. Only the force F is actually observable. Alright. So this is your for electrostatic force. Correct. So gravitation force. So, okay. Now what? Gravitation force. Okay. So as I said, mediator. Mediator means what? Something that, for example, these are two particles, right? This is particle A. This is particle B. So force, according to this, force between two objects act through a mediator. For example, this is called a graviton. So the gravitational force between A and B is what is worked up by what? Graviton. Okay. Graviton actually helps in. It's a theoretical particle. It's what do I say? It's not confirmed yet, but graviton works like A and B interact through gravitons. Okay, this interaction is called a gravitational force. All right, yeah. And for example, there are two bodies again, A and B. For example, they are exchanging a photon. Okay, they are exchanging a photon. Photon is represented like photon, gamma photon. Okay, so this interaction will be called what? Electromagnetic interaction. So gamma photon is what? The mediator for electromagnetic interaction. Alright, electromagnetic interaction. A weak nuclear force. Weak nuclear force is mediated by, again, weak nuclear force will be mediated by what? Sorry. Weak nuclear force will be mediated by something called W boson. Okay, so we give it a dotted lines. It can be W plus or W minus or Z boson. Right. So this is your weak nuclear force, and strong nuclear force will be mediated by gluons. This will be mediated by gluons. It is represented like this. These are called Feynman diagrams. So we'll study them later. Gluons, right? So these are the interactions, and they are mediators, right? Yeah. So how would we know from mediators which one is your attractive or repulsive nature of forces? You can say attractive, attractive or repulsive character of forces. Repulsive character of forces. All right. So there are two types of spin particles. For example, particles they also constitute spin, right? Hmm? Okay. The concept of a mediator is how like all forces are understood in the context of modern particle fields. All right. The basic idea is that any two subatomic particles, okay, exert force on each other. Some type of force on each other, right? Some type of force on each other by exchanging other virtual quanta of subatomic particles. Okay? Virtual quanta. They exchange particles within it. Okay? Subatomic particles. Okay? There are actually what? Say there are actually 12 mediators. You can write down 12 mediators. 12 mediators of what? Non-gravitational forces. Not except gravitation. There are 12 mediators. Okay? One photon is there. We know that photon is a mediator, so one photon, okay, eight gluons. There are eight gluons, okay, eight gluons, then three vector bosons, W plus, W minus, and what? Z naught. Three vector bosons for weak nuclear force. All right. Most these are mostly commonly these vector bosons are mostly what? W plus, W minus, and Z. So far, experimented has indicated that these mediators have helicity 1. This is called helicity. Helicity 1 means what? When I say helicity means simply what? Integer spin. Okay, it's not fractional, it's integer. It's integer spin. It can be h cut like 1, 2, 3, 4, like. Okay, so now from here we can see integer spin, half integer spin. What does it mean? Okay, this one here. So first one is odd integer spin particles. Odd integer spin particles and what? Even integer. Odd integer spin particles and even integer spin particles. Okay. So mediate for this one, odd integer spin particles what? Mediate forces, mediate forces that are both attractive and repulsive. That are both attractive and repulsive. Okay. Attractive and repulsive. And this one is what? Integer spin particles, even integer spin particles, either attractive or repulsive. Only one. Either or. I will only write it as either or. Either attractive or repulsive. Alright. So these can be demonstrated from some basic properties in quantum field theory if you have studied. What this means is, since all non-gravitational forces are mediated by what? Spin 1 bosons. Non-gravitational forces are non-gravitational forces like what EM interaction, or your strong nuclear interaction or weak nuclear interaction. These are mediated by what? Spin 1 bosons, isn't it? See, photon is a boson. Photon is a boson and a spin 1. A weak nuclear is mediated by W boson, W minus, and Z. These are also spin 1. Alright. Strong nuclear is mediated by gluons, which is also a boson. Gluon is also a boson. They all have both what? An attractive and a repulsive character. Okay. But what if you include gravity? These are non-gravitational forces. What if we include gravity? What will happen? The fact that gravity is always attractive means it must be mediated by what? What? It must be mediated by even integer spin, right? Because even integer spin only mediates what? Attractive or repulsive. Gravitational is or attractive, so it must be mediated by what? Even integer spin. Even integer spin. Okay, even integer spin particle. We call this particle what? Graviton. We call this particle graviton. It doesn't have spin as one. It has spin two, right? So the graviton spin is two. Okay. So the Higgs boson has a spin zero. Higgs boson is there also. Higgs boson. Higgs boson spin is how much? S is equal to 2. Sorry, S is equal to 0. Really bad. My bad. So what? This one will have what? Even this is even integer. So it will have a purely attractive character as well. Okay. Yeah. So this is a what? Odd integer spin particles, even integer spin particles. Alright. Yeah. So this is your basically the idea of spin like EM interaction, strong nuclear, weak nuclear, the mediators, the particles that mediate these interactions, all right, and their spins. Okay. So in the next video, we will this will be short videos. Okay. In the next video, we will see the basic properties of more particles like leptons, like fundamental particles like leptons, quarks, and all. Okay. Thank you. That will be for this video.